All right, so we are doing Chapter 2, Section 6 for Item 1 called Ratios and Proportions. So let's start off by talking about what a ratio is. A ratio is a comparison of two numbers by division. So we do this all the time without really thinking too much about it. One kind of easy example is if we think about driving in a car, we're going a certain number of miles per hour. So if I say I'm going 20 miles per hour, I'm comparing two numbers by division. 20 miles per means division, hour, and it's 1 hour. So this is a comparison. It's a ratio of hours and miles. So we're comparing the two. We normally write it like this, MPH for miles per hour, but means the same thing. That's what per means. Another common thing that we like to do, especially in math class, I don't think we necessarily do this, writing a fraction for, say, pizza at home, but you could also do something along those lines where you can say, the number of pieces I have versus the number of pieces that were available, which is what a fraction really means when we're comparing it in that way. So if I say I have a pizza that had 8 pieces, that's my denominator, and now I only have 1 left, I have 1/8 of the pizza. We compare numbers all the time, but a very common one I think that, everybody definitely uses is something like this, miles per hour or miles per gallon, especially once we start driving. We hear these things all the time. Okay, so we're going to move forward. Oops, I'll erase my H. A proportion is an equation stating that two ratios are equal. So now we just have two fractions, and we're going to say they're equal to each other. And we can see down here, we can solve a proportion using cross products. So make sure to convert your units so they are comparable. Number one, they need to be comparable to each other. If you start with minutes and then the problem references hours, you will need to change them both to either minutes or hours. So you wouldn't want to start off with, I'm going 20 miles per hour, like this, a problem with 20 over 1, and then say that equals 50 minutes or 50 miles in 20 minutes. Okay, well now I have hours and I have minutes. That's not really comparable. I need to make sure that it's both the same units. So if I have miles and hours, the second ratio also needs to be miles and hours. So that's all that's saying, is make sure that they're comparable. And then we can solve the proportions using cross products or cross multiplication. So what that means is I have A over B equals C over D. Remember, these are just placeholders, so it's just variables to kind of show us what's happening. Doesn't matter right now what they are, and sometimes we're not told what the comparison is either. Sometimes we're just given some numbers that equal each other, but the fact that there's an equal sign here says we trust that equal sign. So the first ratio equals the second ratio. We just go ahead and trust that that's true. That's what the equal sign tells us to do. So now you can see they did this kind of dotted line, like it literally has dots on it, and they circled the A and the D, so it's a cross product or cross multiplication. They went from top to bottom. And here they are right here, so we can see them, right? Like that. And then I'll do a different color here for the other ones. So now we have to go cross the other way. So we have B and C, and here we have B and C, and we say those are equal to each other. I can cross multiply. And really what we're doing is exactly what we do to solve this equation anyway. So I'll write it off to the side here. If I had A over B and C over D, and I wanted to move this B, what's dividing? I would multiply both sides by B. B divided by B cancels, and remember, it's multiplication on the top, division on the bottom, so the B gets multiplied by the C. So I end up with A equals CB over D. Well, now I don't want this fraction either. I'm going to multiply by D on both sides. So now I'd end up with dA, because we just multiply these together. D divided by D cancels, and I have CB. If I put them in alphabetical order, to make them a little nicer here, it goes AD equals BC, and look at that. It has the same order. Again, I don't like that they're using the X here for multiplication. We shouldn't really be using that anymore in algebra, just so that we don't confuse that with a variable, because they mean times here, but this is A times D. I have A times D there. B times C, I have B times C here. So it's just cross multiplication is doing the same steps we would normally do to solve a problem. It's just doing it kind of all at once. So instead of moving the B and then moving the D, we cross multiply and it kind of happens all at once. So this is just the explanation off to the side on why that would be happening. And you know what, I'll go ahead and leave it there. I don't know why I was backing up. So let's go ahead and try a few of these out on the next page. So these first three, what we're going to do is determine whether each pair of ratios are equivalent ratios, right? Yes or no, justify your answer. So that's 1A, 1B, and 2A. That's what we're going to do. For 3A, this one should have had a little separate set of instructions because since there's an R here and an equal sign, what they want us to do is figure out what does R need to be to make this equal sign true. So we need to solve this proportion to find R. So this one we're not necessarily saying whether or not it's true. We know it's true. There's an equal sign here. We just need to figure out what does R need to be to keep it true. You know, what do we need to fill that in with? But we'll get there in a minute. We're going to do these first. So in order to know if they're equivalent ratios, we could just set them up as a proportion if we wanted to. Go like this. And really we're questioning. This is a question equal sign. It doesn't really mean equal yet. Okay? We're going to do the same thing. We're going to cross multiply. We get 6 times 5. Let me go back to equals. Equals. I think I did dark blue for that one. Oh, why did it do light blue? Did I grab light blue? Dark blue. There we go. And then we have 10 times 2. So now we just need to simplify on this one. And remember, we have question mark here. Question mark. So we have 30 equals 20. That's not true. So not true. So not equivalent ratios. So my reasoning is that the cross multiplication did not work. When I cross multiplied, they were not equal to each other. You could also do something along the lines of, and I usually do this with the smaller one, where I say 2/5. You could do it with the larger one too. You just go backwards from this, but 2/5. If I want to look at 6/10, what do I need to multiply to get 5 to 10? Okay, I need to multiply by 2. If I multiply by 2, because remember, if I'm doing that on the bottom, I need to multiply by 2 on the top. Well, I wouldn't get 6, I'd get 4. So this tells me they're not equivalent, because I wouldn't get the same number if I multiplied by 2 on the top like I did on the bottom. Or if I started with the top, I'd have to multiply by 3 to get to 6. Well, if I multiply the bottom by 3, I'd get 15, not 10. So this is just another way to kind of look at it if you don't want to necessarily do the cross products plan. So let's look at the next one. I'll do kind of both methods again so you can see it. 1/6 equals question mark. Remember, we're questioning this. Over 30. And I'm going to throw my equal sign here with a question mark, so I already have it there. And then I'll do my color coding here. So 1 and 30. 1 times 30. And 6 times 5. 6 times 5. So we just need to work these out. We have 30 equals 30. True. Equivalent. So not equivalent. And you could put yes, equivalent. It depends on what Alex is asking you in the drop-down menus. It'll probably ask you for different types of answers. But whenever you have to do a word answer, there's going to be a drop-down. It's not going to have you type in a word because then it has to worry about your spelling. And we're not marking you off on spelling. We're seeing whether or not you know the correct answer. So by having a drop-down, it eliminates that type of idea on Alex when we do that. You just have to choose the correct answer as opposed to spell it correctly as well. So this one is equivalent. So I could do that same idea that I did on this one, and I could go 1/6 and then 5/30. Well, to go from 1 to 5, I'd have to multiply by 5. 1 times 5 gets me 5. So if I do that same thing on the bottom, 6 times 5 gets me 30. Check. That guy works. So they are equivalent. So again, either method, it doesn't really matter which one you use. To check equivalent ratios, but this is definitely what we're going to use in the future. We're going to use proportions because we're going to be given proportions to solve. So that's why I'm kind of practicing both there. I like that idea. So 0.2 over 1.8 equals question mark 1 over 0.9. And this is, I say 0.2, but it's 2/10, 1.8, or 1 and 8/10, and 9/10 would be how you say that. But, I was just being a little lazy there when I said it the first time. All right, let's go ahead and do our cross multiplication. Whoops. Going to the wrong one here. 2 and 0.9. So 0.2 times 0.9. And this is I'll make that a bigger dot because these are my decimals here. This is my multiplication dot. And blue. So we get here. So we have 1.8 times 1. Let me switch my colors over. I know this is very colorful here. So this one is, really easy. Anything times 1 is itself. On this side, you can actually treat this just like you would 2 and 9. So 2 times 9 gets me 18. Well, 0.2 times 0.9 also gets me 18, but I have to take into account that it's decimals. So it's not going to be just 18, it's going to be 0.18 or 18 hundredths. So just, keep in mind, I can still treat these the same. 2 times 9 still gets me 18. I just have to keep into account there's decimals, and you can even say 2 times 9 is 18. I have 1 decimal place, 2 decimal places, so that's how I know it's 2 decimal places. So it's just, understanding decimals and multiplying there, but you can do that definitely. So 0.18 or 18 hundredths equals 1.8 or 1 and 8/10. Well, no, it doesn't. Those are very different, right? This is like, if we're thinking about money, this is 18 cents. This is $1.80. Those do not equal each other. Not true. So not equivalent. Equivalent. How could I do this with this step? Because some students see this and go, I don't really know how I would do this. What you could do is you could multiply everything by 10. Because what that'll do is it'll get rid of all of the decimals. So if I multiply everything by 10, boop, 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 what it's going to be is 2 over 18 equals 10 over 9. So it's all, I just moved all the decimals over. So now it's a little easier for me to picture. And actually, I'm going to take away the equal sign. We weren't doing that on that side. But now I can kind of picture, if I do 18 divided by 2, because you can also go from larger to smaller. Well, 10 divided by 2 is definitely not going to get me 10. It'd get me 1. So this doesn't work. So this is x. Or I instead of x, because it looks like times, I'm going to put a big no. No. So those are my no's. So I put a check mark in that one saying, yay, it worked. This one does not work. Whichever way you decide to do this one, it doesn't work. I can't turn 2/18 into 10/9. Or 2/10 into, the 2/10 and 1 and 8/10 into 1 over 9/10. I can't turn it into these pieces the way I would like to. So let's go ahead and do number 3 here. So number 3, like I said, it already has an equal sign. So we're not testing if this is equal. There's no question mark anymore here. That is for sure equal to each other. They're telling us that. Now we just need to go through our cross multiplication here and figure out what does R need to be in order to make this true. So we start doing our cross multiplication. We have R times 40 equals 8 times 25. 8 times 25. And switch my colors again here. So R times 40 is just 40R. So, and R40 is not wrong. You could write it that way, but the correct way to write it is going to be the coefficient and then the variable. Either way, it means multiplication though. And with this one, we can even think about quarters. I really like money when I'm thinking about multiplication. Sometimes for some reason it makes it easier. But if I have 8 quarters, then I know I have $2, right? Or 200 pennies. So I kind of quickly do that kind of stuff in my head when it's, tens, fives, 25. It's something really easy to relate back to money. For whatever reason, I like that. All right, so let's go ahead and solve this. We're multiplying by 40, so I'm going to divide by 40 on both sides because I want to do the opposite. And that gives me R equals, so 200 divided by 40. So very quickly I can cross off these zeros. That's a quick cancellation I can do. And then I can do 20 divided by 4, and I get 5. So if you didn't know right away that 200 divided by 40 is 5, that's fine. You could, do the division, just 200 divided by 40. But if you have zeros on the end of your numbers, those cancel immediately. It's dividing by 10. That's what we're doing on those. So both of those reduce immediately by 10. And then 20 divided by 4, well, that's a little easier. I know that's 5, right? So R has to be 5 in order to make this true. And I can even think of it the same way that I was thinking of the other ones and go like this. I have R. So what do I need to do to multiply, or what I need to multiply 8 by to get to 40? I have to multiply by 5, right? So I'd have to do the same thing on the top here. I'd have to multiply R by 5 to get to 25. Well, what would I need to multiply? What times 5 gets me 25? 5. So it's a little bit more. You have to figure out what am I multiplying or dividing by, and then kind of apply that backwards to say, okay, well, if I know what I'm multiplying by, I know what I'm getting, what did I need to start with to get the right answer? So you can do it this way, but definitely, I'll go ahead and leave it there. I don't know what I was undoing. This is the common way to do it. This is the way we're going to expect to see you to do it because it's set up as an algebraic equation this way. All right, that was the end of section 6, and I will see you in, I believe, section 7.